Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over section 4.1 of our virtual geometry text on triangle properties. We're going to be looking at how to use the Midsegment theorem to solve problems involving a triangle. So, for example, we have an example here. You want to find the length of KL given this triangle and the midsegment. Don't forget, we have 6 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of the contents of this tutorial. You can gain access to our Algebra 1, Geometry, Pre-Calc, Algebra 2, and Calc courses in the links in the description below. Alright, to get us started, we're going to be taking a look at the Midsegment theorem. So this is our website, mathgotserved.com, under Geometry. And we're going to scroll down to the collection of theorems and postulates, and here you can see the midsegment theorem. So the midsegment theorem just basically says if you have a midsegment, as you can see here, DE, and the definition of the midsegment is a segment that connects the midpoints of two sides of a triangle. All right, so point D is a midpoint of CA and point E is a midpoint of CB. So if you have a midsegment, you can arrive at two conclusions. Number one, the midsegment is parallel to the third side, and the midsegment is half as long as the third side. So we're going to be using the second conclusion in solving the problems that we're working on today. All right. If you want to gain access to this theorem and other valuable resources, you can always visit our website at mathgotserved.com/geometry. All right, now let's take a look at some examples. So for question number 1, let's say we are to find the length of segment SQ. We want to find SQ. All right. So what we're going to do first is we're going to write down the conclusion that we can arrive at using the midsegment theorem. Okay, so UV is the midsegment, as you can see here. So UV is going to be half as long as SQ. All right, so UV is equal to 1/2 SQ. Or you can say SQ is twice UV. Okay? All right, so this is the equation that we can write using the midsegment theorem. Now, we're not going to substitute what we know. We know that UV is 8 units long. And then we're going to use this equation to find what the value of SQ is. All right, so let's solve this algebraic equation for SQ. To accomplish that, we need to get rid of 1/2, so just multiply both sides by 2. And then you're going to get your final answer. Segment SQ is 16 units long, which makes sense, right? Because the midsegment is half as long as the third side, so you should expect this to be double that. So SQ is 16 units long. All right, let's take a look at number 2. So for number 2, we're going to start off by writing down how the midsegment applies to this case. Okay, so the midsegment tells us that the midsegment, which is QR, okay, because it connects the midpoint of segment G, H, and GF. Midsegment is 1/2 the length of the third side, which is 1/2 FH. Okay, so let's go ahead and substitute what we know and what we need to find. We need to find QR, and we know that FH is 4, so we substitute 4 there. So what is 1/2 of 4? 1/2 of 4 is 2, so QR is 2 units long. Okay. All right, so we did some straightforward problems. We're going to up the level of complexity slightly. Let's take a look at this. So for number 3, let's say we're to solve for x. Okay, solve for x. All right, so let's do this. So to get us started, we're going to write down the midsegment theorem as it applies to this particular scenario that we're working on. So the midsegment QP is equal to 1/2 the third side, which is IG. Okay, so write down the theorem. Now we're going to substitute QP is the expression 2x plus 23 equals 1/2 of IG, which is x plus 16. All right, so there are two ways we can solve this problem. We can distribute 1/2 and then solve for x, or we can get rid of the fraction completely and then solve for x. So most students don't like to deal with fractions, so why don't we go ahead and get rid of it? So what we'll do is multiply both sides of the equation by 2 to get rid of that fractional coefficient there. So that yields 4x. So what we're doing right now is distributing this 2 across these two terms in the parentheses. So you have 4x plus 46, and then these 2 and this 1/2 divide out equals x plus 16. Alrighty. Okay, so let's collect like terms. All the terms with the x's, let's collect them to the left side, and then let's put the constants on the right. So we're gonna subtract x from both sides of the equation. All right, we're flexing our algebra muscles here, and then we're gonna add 46 to both sides of the equation. Oh, actually, I take that back. We subtract 46. We do the inverse. So sorry about that. Subtract 46. Since we have plus 46, in order for it to cancel out, we need to do the opposite. All right, so subtract 46 from both sides of the equation. All right, so what we're doing right now is just doing two steps simultaneously. So let's go ahead and see how that looks like. All right, so what's going to happen is as follows. On the left side, so on the left side, 4x minus x is just going to be 3x, and then my plus 46 minus 46 add up to 0 equals x minus x, cancel out, and then plus 16 minus 36 will give us negative 30. All right, to finish this off, we'll just simply get rid of this coefficient of 3, just divide both sides of the equation by 3, and that will give us our final answer. And then our answer is going to be x equals negative 10. So we have x equals 10. Okay, no, x equals negative 10. All right, so let's go ahead and take a look at the next problem, question number 4. Take a look at question number 4. So we're going to be following the same procedure as we did in number 3. So what we're going to do first is write down the mid-segment theorem. So the mid-segment is JK, and that is half as long as the third side, IG. So let's go ahead and substitute. The mid-segment JK is 14 plus x is equal to 1/2 the third side, which is x plus 17. Alrighty, so let's get rid of this fraction. As we did here, we'll just multiply both sides of the equation by 2. So you multiply both sides of the equation by 2, so 2 gets distributed to these two numbers on the left side, and then we have 28 plus 2x is equal to, and then these two divide out, is equal to x plus 17. All right, so let's move all the variables to the left side and the constants to the right. So subtract x from both sides of the equation. This is positive x, so you do the inverse to move it to the left side. And then positive 28, you subtract 28 from both sides of the equation to have the constants on the right side of your equation. Okay, so you combine downwards, and then you're going to have 2x minus x is x. X equals, and then this adds up to 0. And then 17 minus 28 is negative 11. And ladies and gentlemen, that is the answer to question number 4. All right, let's go ahead and try problem number 5. This is slightly more involved. So in question number 5, we see that the mid-segment and the third side are both variables. Okay, they're both expressions. We don't know what they are, but we're not solving for x. This was the case with 3 and 4. Alrighty, in this particular case, we are looking for the measure of the mid-segment itself. How long is KL. All right, so that's what we want to figure out. So this kind of problem is a two-part process. So let's go ahead and specify exactly what we're going to do in this problem so that we can avoid making mistakes. All right, so what are we going to do first? What we're going to do first is as follows. So let's call this our steps. So first step is to find x, okay? And then number two, we're going to use x to find KL. All right, so use x to find KL. A big mistake many students make is that they do not solve the problem completely. They just find x and they think they're done with the problem, whereas you're not. So outline the steps before you start and make sure you follow it. Okay, so part one, we want to find x first. Okay, so to find x, what we're going to do, we're going to use the Midsegment Theorem, and then we'll use algebra to figure out KL after we're done with that. All right, so what's the Midsegment Theorem? Let's go ahead and identify what our midsegment is. All right, so so let's go ahead and mark it. I didn't mark it. So in this particular case, this is, all right, so I'm having some technical difficulties here. All right, so the mid-segment is LK. So if we use a mid-segment theorem, LK is equal to 1/2 of CE. All right, so let's go ahead and substitute. LK is 2x minus 1, and that is half as long as the third side, which is 2x plus 10. All right, so don't forget what we're doing. This is just part one. We're solving for x. Alrighty, let's get rid of this fraction. Multiply both sides by 2. If you do that, on the left side, we're going to distribute this 2 across these two terms. And that's going to yield 4x minus 2. And then on the right side, you notice that this 1/2 and 2 cancel out, is equal to 2x plus 10. Alright, so let's go ahead and get x isolated, so we're going to use algebra for that. Subtract 2x from both sides of the equation. Alright, I'll move the constants to the left and then add 2 to both sides. When you're done with that, combine downwards, and then you get this adds up to 2x minus 2 plus 2 is 0 is equal to 12. And then divide both sides of the equation by 2. And then we get our intermediate answer, which is x equals 6. All right, so now we're going to advance to part 2 of the problem. To finish it up, for part 2, we're going to want to find KL. Alrighty, so we know from the given figure that KL is what? KL is 2x minus 1. Okay, that's what's given, but we know what x is, so we just substitute this 6 into the x and evaluate. Okay, so KL upon substitution is going to be 2 times 6 minus 1. And then we just use PEMDAS to finish this up. Multiply first. 12 minus 1 is equal to 11. Ladies and gentlemen, that is the value of the length of segment KL, the mid-segment of the triangle. All right, now it's your turn to do some practice problems. We have 6 practice problems for you to try out. So go ahead and pause this video at this time and work on these 6 problems. When you're done, click on the playback button and we're going to reveal what the correct answers are. Welcome back. Hopefully you had a chance to try out the problems. Let's look at the answers. Number 1 is 12. Number 2, XW is 2. For number 3, X is negative 12. For number 4, X is, what is X for number 4? X is 9. For number 5, JK is 10. And then for number 11, TV is 24. Okay, let's write that down. TV equals 24. All right, so how well did you do in these practice problems? Let us know in the comment section below how well you did. And if you have any questions, specify it below and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your studies of the mid-segment, to give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel where you can get updates to other cool presentations such as this. You can also gain access to tons of support resources at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.